In this video, we're going to look at units. Units are really important in physics because, or in general in life, because it doesn't make any sense to say I've traveled 50 or it's been 30 since I've done something. So in physics, we have very specific units for our physical quantities, but there are even more special units called base units, which go with the base quantities. So these are the quantities and units which every other quantity we use in physics are based upon. They're made up of these. I'm going to introduce 5 base quantities and their base units that are used in high school physics. There are a couple more, but they're not really relevant to studying physics at this level. So the first one is length, and that has the base unit of the meter, or the lowercase m. Then there is time, which has the base unit of the second, or lowercase s. Then there is mass, and not weight. Weight is a force, and that needs to be dealt with in a different way, and that is derived using mass. But mass has the units kilogram, or lowercase kg. And another important one is temperature. But in advanced high school physics, we need to use a form of temperature measurement which can go down to 0 without any negative numbers. So 0 being the coldest possible temperature you could ever have. So there are no negative numbers. So this is why it's called absolute temperature. And the base unit for this base quantity is the Kelvin, and it has the symbol uppercase K. And finally, we will include electric current, which has the base unit ampere, often spoken as amps, and have the uppercase A as its base unit. So these base units are used to define all other units. So if I take an example of a relationship in physics, a formula which is well known generally, is force equals mass multiplied by acceleration. Now, in terms of the units, the unit of force that we use in physics, the System International, or SI unit, is the Newton. So that has to be equivalent, according to this formula, of the units of mass and the units of acceleration. Well, mass is a base quantity, and we've said that it has the base unit kilogram, kg. And acceleration, known generally in physics to have the units meters per second squared, written like this, ms to the -2. The base units on the right side of this equation then are equivalent to a Newton. So that's how we would write the base units, or the unit Newton, in terms of its base units. And we can see that all of these parts on the right side appear in the base units which we introduced earlier, whether it's mass, a bit of length, and a bit of time. Now let's look at an exam question just to clarify this, to test this situation. So here we have an exam question which is from Pearson Ed Excel A-level summer 2024. And it's about this idea. So which of the following is the base unit for charge? Now, the first thing you might see is that the symbol for charge is there, Q. So could this be the answer to the question? Well, no, because That is the symbol for the quantity charge. It's not the unit. It's not the symbol for the unit of charge. Then if we know a bit more, we might say, well, oh, there's the unit for charge, Coulomb, B. Could that be the correct answer? Well, let's just check with our base units. Does the Coulomb with the symbol uppercase C appear in any of our base units here? Well, electric current is probably the closest relationship. And no, the base unit we use is the ampere. And just to check, it's not in any of the others. So we're going to discount that one. Now, C doesn't look anything like what we're looking for, but we'll go to the correct answer, which is A, and explain why. So if we go to the formula sheet that's supplied with the exam paper, we will see that there is a relationship between current, change in charge, and change in time, this one here. So that will help us work out what the base units, what the units for charge will be in terms of the base unit. So we're going to write that relationship here. So I won't worry with the delta, which means changing. So I've got I equals Q over T. If I rearrange this, then Q, the symbol for charge, is I times T. So if I now put in the units, now the units for Q, which you don't really need to know to solve this, but they are the Coulomb, must be equivalent to the unit for current, which is the ampere, multiplied by the unit for time, which is the second. And they are both base units. Remember, we have the ampere there and we have the second there. So that is why A is the correct answer. Okay, thank you for watching.